The second part of chapter 1 is dedicated to the science in primary education, the Spanish curricula. We will revise this the next slides in Spanish. El marco normativo de la educación, el marco educativo reglamentario en España viene descrito por dos decretos o reales decretos, el Real Decreto 126/2014, que es el decreto por el que se regula el currículum básico de educación primaria. Lo podéis encontrar en el BOE número 52 de 1 de marzo de 2014. Y la adaptación al currículum regional lo podéis encontrar en el decreto 103/2014, por el que se establece el currículo de educación primaria en la Comunidad Autónoma de Extremadura. Os invito a que busquéis ambos decretos, ambas normativas básicas, y las visualicéis. No será objeto de contenidos en esta asignatura, pero altamente recomendable que reviséis cómo se estructura el currículo básico en educación primaria, su traducción al decreto extremeño y cómo se estructuran, pues en este caso, los contenidos de educación primaria de educación científica a lo largo de la educación primaria. Well, so what is a science curriculum? So we need to, although I'm sure you already revised those concepts in other subjects, we can say like a curriculum is like a teacher's intended plan that teacher used the presiding syllabus and the school policies in consideration of the students' development levels. So in this intended plan, the teachers would need to take into account contents, how to teach these contents, and how to assess this content. We need to program a unit or like a whole year considering like those things. In science, we need to keep in mind what we said before, like learning science is an active process, like a need to be done by students. So in this process, we need to use questions to investigate science. It's very important to foster our students' curiosity for all the things that they are happening outside. So to investigate, to ask questions, answer questions. Second, encouraging students to propose a hypothesis why a particular thing is happening. So how like a student suggests this hypothesis and how they check this hypothesis right or not. So also we need to engage students in hands-on experience. This is very important to do like a little lab experience in the classroom, like a little research, little searches. So what we said before, like a science need to be learned by the student doing science. And finally, presenting the students with opportunity of collaboration, so like a cooperative projects, like a different strategies to work together. Because also we need to keep in mind that science is not done by a single person, like a scientist. The image of like a scientist doing everything is not right. Science is done by a team of scientists, so it's very important to collaborate. Well, in the last part of this chapter, of this section, is like instructional models to teach science. We will revise very briefly different models to teach science, and we will describe them with some examples. Why science is such a difficult subject? So why people think science is so difficult? Well, maybe because of conceptual contents. Sometimes we are talking about very like theoretical contents, very like contents that need a lot of mathematical knowledge, using like a high formal requirements, like in order to understand like some scientific context, we need to understand other requirements. We need another requirement, like basically math requirements, like physical requirements. And a very important factor that limit or like makes science a difficult subject is like our initial ideas or misconceptions. Misconceptions are those ideas that everybody have in their mind, and they are not accurate, they are not scientists. Uh, so those idea is very important to know them because having like a grown idea about like a scientific fact may lead a not very proper way to learn. So many students think that learning science consists of memorizing retained conceptual definitions and using complex mathematical equations without the need without no need of understanding. We already know like this is not right. We said a couple of times already like learning science is to learn how to do science, and this is nothing related with memorizing conceptual definitions and using complex mathematical equations. So, did traditional teaching strategies lead to this thought? I guess so. I guess so. Like traditionally, like a science was taught uh, based on memory, based on like memorizing like this concept and apply them using mathematical tasks. But it's more than this. It's more than this, and we will try to do this during this year. Um, we are going to revise three models: transmission reception model. The students learn the scientific content provided by the scientist. We are going to use the second one is inquiry-based learning model of teaching or discovery learning. In this model, students are encouraged to ask questions and formulate their own tentative answers. And the last model we will revise is constructivist model of teaching. The new scientific knowledge is built over the previous learned knowledge. So let's start with the first one. Transmission reception model of teaching. In this model, the pupil student is considered as an empty book to write in. A student came to my class with a very empty mind, and I, as a teacher, need to introduce concept to write in this empty book all the content I want to teach. So, who is the teacher? What is the teacher duty? To provide the knowledge. Teacher knows all the contents and need to deliver them to the student who insert them in their mind. So the basic instruction formula is a lecture. Normally, like this transmission reception model, like I prepare a lecture, I came to the class, I give my lecture, a student take notes, and learn, memorize this lecture, and that's all. And assessment, the learning tool will be memorized. The student need to memorize my lecture because in this lecture I provide all the knowledge they need to know. Well, assessment, a student repeat what they have memorized. This strategy, obviously, we don't like it. We need to avoid this strategy. We have to use it in like some occasions to introduce new concepts, very difficult questions, or sometimes we need to use it and it's useful, but we don't have to base our daily teaching basis in like a transmission reception model. The main disadvantage is the students' previous idea are not considered. We don't know, we don't care what a student already knows, what a student background. We don't have any interest in this because we think our student is an empty book to write in. Some advantages: it may be useful to clarify some concept or introduce new topics. It's very important that although we think like a transmission reception is not the most appropriate model of teaching, it's also important to know like sometimes we need to use it. So what is the structure, an example of this model? So normally as a teacher, first we need to do an introduction. In this model, like in my lecture, I will start introducing the new concept, like make a contest where I'm gonna teach this concept. Then once I did already this introduction, I introduced the new concept, definition, classification, examples, plots, graphics. I will establish relation between new and old concept to link them in the student's mind, and some application, solving problems, lab experience. Well, although we said that transmission reception model is not the most appropriate, also it's true that is the most frequently used model. So why is the most frequently used model? Because sometimes people consider or teachers consider that teaching is an easy task and no training is required. So because it's easy task, teaching and learning is just a transmission of knowledge from the teacher to the student. If in the case there is some problem, like a student doesn't learn my class, the concept I'm teaching is because of the students. It's always the student's fault. According to this idea, is because of lack of ability of the students or because the students have the basic concepts. So, but we know this is not true. Teaching is a very difficult task, and we need to learn how to teach, and we need to learn how to use our strategies. And as I said before, transmission reception model is not the most appropriate. We need to use it in like a very limited occasion. The second model we said before is discovering learning. In this discovering learning, students learn what is discovered by themselves. So what is discovered provides a more effective learning. So if you link this idea with what we said before, like a science need to be learned by doing science, so this is matching our point, because students learn what they discover. So, like in this model, teacher need to advise the student, need to guide the student through this learning, need to teach, need to show them how to discover, how to ask questions, how to find the answers. In this case, like instruction is a process and activities centered in the students, in the learning, centered in the science. We need to provide student situations to learn the concept we want to teach them. And here, the learning is the application of scientific method. Well, the assessment will be the process, not the results. We put our attention in the process to generate this discovery. So we need to assess the process. The main disadvantage is very difficult to apply in a very big groups, and very difficult to achieve the same results in different class situations, because we are letting the student to guide or to control their classroom. So it's kind of difficult to handle this in a very big groups, and sometimes we are not reaching the same results. For instance, what is a discovery learning step by step? So we can provide experience and contests that make the students willing and able to learn. For instance, we can ask why a big aircraft is able to fly. So instructions must be a structure so that it can be easily grasped by the student, like a spiral organization. Collect the information they know and establish the way to get information they don't know, experimentations like a library research, and apply the collect information to provide a suitable answer and evaluate the results. After the whole process, a student needs to be able to answer why a big aircraft is able to fly. Proper answer, proper experiment, designs, alternative. So, as I said before, as a teacher, we need to guide the students in the proper way, to focus in the concept we need to teach. So, for instance, if students need to answer this question and start to research things that we consider is not related with the topic, we need to reconduct them to the proper way. We need to advise them in order to achieve the learning goals. What are the potential advantages and disadvantages of this strategy? So advantages: supports active engagement of a student in the learning process, because we are asking very precise and very specific topic. A student may be highly interested in this topic, and since the students will learn in somehow in a process while they're discovering, this is a very engaging environment. Also foster curiosity. This is also a key factor for learning science. And able to develop a lifelong learning skills, because we will teach the student how to do research, how to collect information, how to make hypotheses, how to contrast them. Personalize the learning experience. Also, the way we select the topic to learn will be associated with the student. We can like a search what the student want to learn, how the student want to learn, provides high motivation because the student have the opportunity to do experiments to prove their hypothesis, and builds on the students' prior knowledge and understanding. Yeah, this is also a key factor. We in contrast of the other model here, we do consider what the student already know. But also we need to keep in mind there is some disadvantages. Confuse the students if no initial framework is available. If we don't have like an initial framework or initial starting point and very clear situation, may get some confusion in the student. Also, is can be very inefficient and time consuming in order to like place the content. I mean like in order to reach some specific goals, it takes a lot of time. It can lead to student frustration if they cannot answer the question, or if they cannot like find the proper answer, or also they don't know how to study, or they don't know what contents are in the chapter, in the unit, and difficult to get the same results in different class contexts. Yeah, this is also a very important, because as a teacher we need to achieve some goals, some learning goals from the teaching point of view, so we need to ensure like a student reach. So we need to keep in mind this strategy is better than the other, but also, as I said, have like a very important disadvantages. And finally, and the most important model is constructivism. Tradition of constructivist model of teaching. In here, students, learners are the builders and creators of meaning and knowledge. Teachers guide the pupil in the learning process. Instruction is like a scaffold to learn process. I mean, we build a scaffold where the contents are arranged, and we like help the students to achieve this knowledge. And learning is involved inventing ideas rather than mechanically accumulating facts. So here, obviously, we need to consider like all the previous ideas, and like we need to, based on them, build new knowledge. Assessment is like overcome conceptual mistakes. So, as Auswell said, the most important single factor influencing learning is what the learner already knows. So, if you know what the student already knows, it will be much easier for them to learn new concepts. So, what is the step by step? So, what the learner already knows. So, we need to start our classroom asking open question, tests, quizzes. So we need to know as a teacher what my student already know. Also, we need to know if these ideas are correct idea, or there are like a conception or misunderstandings. So we need to debate about the known ideas. We can do it in a small group or even like a big group. So new ideas occurs as we adapt and change our old ideas. So we need to know, because we already know what my previous ideas, I introduce new idea based in the previous one. So we need to like work with two concepts, and we will see now is cognitive conflict or conceptual change. And as a result, we will use the new student's idea in a different context. So I don't know if you follow me. So, but basically, it's like learn what the student know. Based on that, make my instruction like introducing new ideas, changing the initial idea of a student, evolving them to new ideas, and then asking the student to apply these new ideas in new situation. Here is like a little sentence, a little slide I invite you to read carefully about why is constructivism so important. And we will finish this chapter using saying very briefly different strategies, techniques, and resources to teach science. So there are project inquire, science field trips, project-based learning, conceptual maps, lab, model, mock-ups, games, lecture. So those, all of them are different strategies to teach science. And all of them we will try to revise during the whole year.